Page 4 continues graphing the exponential functions. So the first thing I might do is go ahead and Eric is so funny. 4 times 1.25 raised to the x and then plus 2. So I'm going to type that in and go to the graph. My window is good. Negative 8 to 8. Well, I might as well. And negative 4 to 30, that's going to be good. Okay, graph. So I can see on this one we're actually dealing with a growth. And it's kind of a slower growth than the last one was decay, which is kind of interesting. So it is growth. And the rate is, remember that this is 4 times 1 plus or minus the rate to the x plus 2. And the rate is how much further away from, or how far away it is from 1. And in this case, it's adding 0.25. So we are adding. So it is a growth rate of 0.25 or 25%. Domain is all real numbers. We're going left to right. All real numbers. And range, well, let's go ahead and start plotting points to see. So range, we're going to go to second table. And I'm going to start over here at negative 8. At negative 8, we're at 2.67. So at negative 8, we're at 2.67. So there's 3 and 2 point, somewhere in there. And we're at 2.8. So getting closer to 3. 3, so basically halfway between 3.3. Somewhere in there. 3.6. 4, basically 4.5, 5.2, so there's 5, so 5.2 is like right there, 6, 7, 8.25, so here is 8.25, 9.8, which is almost 10, 11.7, so almost 12, 14.2, 14.2, and 17.2, 17.2, and 21 is right here, and 25.8, 25.8, so somewhere in there. Now, what you don't see is, I'm going to go further to the left, and what I can tell is that this is getting closer and closer and closer and closer to 2, which is the vertical shift, and that's always going to be your horizontal asymptote on a exponential growth or decay. So if you ever, if you can remember that is just where your where it flattens out to. So I know this is at 2, so I'm going to go ahead and graph that. So my horizontal asymptote, y equals 2. And I need to connect the points. Part of the points is graphing the function. So, will I give one that you have to plot so many points on? I don't know, but if I did, then you would do it. Because if you care about the points, then you'll just graph them. It doesn't really matter, it's just plotting points. Okay, my x-intercept is where we cross the x-axis. And the fact that this is a horizontal asymptote above the x-axis means it will never go below that. So I, in fact, have no x-intercept. Range is low to high, and the lowest this function goes is 2, never reaching it, and then up to infinity. My y-intercept is where I cross the y-axis, and from graphing it, I know that when x equals 0, the y value was 6. Yeah, I don't need to show it. So when x equals 0, the y value is 6. And then the average rate of change. So the average rate of change, remember, is the slope. So we've got an x, we've actually got 2 x values, 0 and 2, and I want the corresponding y values. So at 0, we're at 6, and at 2, we're at 8.25. So the slope formula is y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2, as long as they're in the same order. So I'm going to say 8.25 minus 6 over 2 minus 0 That is 2.25 divided by 2, which is 1.125. And that is my average rate of change. Oh, and behavior. Forgot that. The limit as x approaches negative infinity, and the limit as x approaches positive infinity. So as you go left, the function is actually going to 2, and as you go right, the function is going up to infinity. So there is that. It's growth, 25% rate, all numbers, 0, 6, 9, 5 plus 2, and 1.125. Alright, number 18 says use exponential growth or decay to solve each problem. So you've got to remember your different formulas. I'm going to go up here real quick and talk about them. So if you have annual, if you're talking about money, amount equals principal times 1 plus r to the t, 1 plus or 1 minus if you're increasing or decreasing exponential growth or decay, which is percentages, growing or decaying by percentages. K times a year, if we're talking about compounding money, K times a year. That is amount equals principal times 1 plus, always plus, r over k to the kt, because we're assuming that we're investing in accounts that are going to grow. And then if you're in a continuously compounding function, compounding, k times a year or continuously. This is amount equals the principal times the exponential, the natural exponential exponent e, and then raised to the rate times time. Okay. That is an r. So let's talk about the different, what k could equal on the k times a year. If we're talking annually, k is 1, so it's just basically this function up here. If you're talking semi-annually, that's twice a year. Quarterly, it's every quarter, so that's 4 times a year. Monthly, k equal 12. Weekly, 52, and daily is 365. Okay, let's go to 18. A $25,000 car depreciates 9% each year. When will it be worth $10,000? So we're talking about just an annual depreciation of 9%. So that is this first formula. The initial amount of the car is $25,000, and it's 1 minus 0.09. 9% is 0.09 to the time equals. Now I want to know how much time will it take for it to equal $10,000? So there's two different ways to do this. One is to graph and find the intersection, and I'll take you through that in a second. The other option is to use the algebra that you've learned since learning this this lesson, or this topic. So I'm going to go ahead and do that graphically. That's the way we first learned it, and then I'll show you how to do it algebraically. So y equals, I'm going to graph 10,000, and I'm going to graph 25,000 times 1 minus 0.09 is 0.91 raised to the x. Now I got to make sure I'm going to be able to see, so I got to remember x represents time, so I'm going to go 0 to, I don't know, 40 years. And y represents money, so I'm going to go 0 to 30,000, just so I can make sure I can see everything. So I see my 10,000 and then my model representing the worth of the car. So I want to find that time. So I go second calculate number 5, the intersection. And I don't have to get closer to it, but I wanted to. So press enter, 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 just to find the intersection. And it says when we're at 9.716 years. So it would take 9.716 years, basically 9 3/4, for it to depreciate $15,000. Here's the other option. Do it algebraically. So that is graph y1, y2, and we did window. X was 0 to 40, y was 0 to 30,000, and then second calc, intersect. Algebraically, I would just do this. 10,000 equals 25,000 times 0.91 to the x, or t, doesn't really matter. I'll just change it to t. Alright, I'm solving an exponential equation, so I want to get the exponent alone. I'm going to divide by 25,000. So divide by 25,000. Ten divided by 25 is 2/5. The video is off a little bit. Okay. That's better. So we're at 2/5 equals 0.91 to the t. And in order to solve an exponential equation like that, we just convert it into a log. So I've got log base 0.91, that's the base of the exponent, so it's base of the log, of 2/5 equals t. And so that is just the log expression of that exponential. So just converted it to a log. And I go to my calculator and go alpha y equals, alpha window, number 5, and 0.91 of 2/5. And I get 9.716, which is the exact same thing. 9.716. I'm going to go ahead and put years. Let's make sure we put a unit on that. Number 19, I'm given that the principal is 20,000 and then multiple parts. So let's go ahead and see what it's asking me to do. If the money given is invested into an account that compounds semi-annually, so that's when k equals 2, at 5.7% interest, what would the equation be for the amount of money in the account? So amount equals initial amount, the principal 20,000, times 1 plus r, which is 5.7, so it's 0.057. Make sure to put it as a percent. Divided by k, and k is the number of times, so that is 2, number of times to compound per year, raised to the 2 times time. So don't forget, amount, principal, rate over number of times compounded, raised to the number of times compounded times the number or the amount of time. This is a formula. This is the answer to part A. This is the amount at any time t, right? Now part B asks how much money would be in the account after 20 years. So that means I actually want to find the amount when 1 plus 0.057 divided by 2 when time equals 20. So we're just going to go to the home screen and type that in. 20,000 times 1 plus 0.057 divided by 2 raised to the 40th power. And I get $61,546.28. That's the only time you're allowed to go to 2 decimals. Alright, part C asks for if the amount of money given, if the money given is invested in an account that compounds continuously at 5.6% interest, what would the equation be for the amount of money in the account? So that's the PERT formula. Amount equals principal times E, and it's just E. You don't have to put anything in for E, to the 0.056 times time. So that is the amount formula at any time t. Part D asks how much money would be in the account after 20 years. So amount equals 20,000 e to the 0.056 times 20. So I clear that out and I type in 20,000 times e to the 0.056 times 20. Okay. And I get $61,297.08. So it says, Part E, which account is better for the first 20 years? Well, considering the fact that this is $61,546 and this is only $61,297, then I would say the compounding semi-annually at 5.7% is better. For these 20 years. I don't know about the rest, but I can definitely say for these 20 years I get more money. And the other one. So there's my answers for all of those. Alright, last question's on the page 4. Rewrite in exponential form. So remember that the base log is the base of the exponent. So this is x to the y equals 52. And if you're ever unsure, you can always say log base 3 of 3 equals 1, and then see if it makes sense when you write it like this. This is going to be, well, I'll show you another one. 3 to the 1 equals 3, and that makes sense. You could say, I know log base 3 of 9 equals 2 because this is 3 squared, right? So you could say 3 squared equals 9. If you have anything that makes sense to you as a key, then like you could say, okay, log base x, so x is the base, 52 is 9, so that goes over there, and y is 2, so that goes there. If you have anything to use as a key, then that kind of helps you out. But it is just that format. The other one, this one over here, base of the log is base of the exponent, so v to the u equals 36. And there we go. And that is page 4.